morning, viewers. Myself, Muniraju Naidu, Assistant Professor, Department of Computer Science and Engineering, Institute of Aeronautical Engineering, Hyderabad. So, in this video, I am going to discuss about DNS in application layer. So, what is DNS? What is the purpose of DNS? And what are the various applications of DNS? So, we know DNS, which represents a domain name system. So, these are the concepts like introduction, services, and what are the various DNS servers. See, just like our human beings, the systems can't communicate with each other with the help of their names. So for that, here, in case of networking, computers do not represent by names like humans, but they represent by numbers, because that is how computers can communicate with other similar devices. They need to talk each other and identify each other over any particular network. So, which is using numbers such as IP addresses. So, that is Internet Protocol addresses. See, here DNS stands for Domain Name System. So, the basic purpose of DNS is DNS resolves names to numbers. So, because only systems identified with the help of the numbers only. So, that's why DNS resolves names to numbers to be more specific it. Which means DNS resolves domain names to IP addresses. So, if you type any web address in your web browser, automatically DNS will resolve the name to a number, because you know one thing, the systems can knows the only numbers. So just like our people, we have many identifiers like SSN, name, passport. Whereas the routers and internet hosts, which is having one unique ID, that is the IP address. For example, www.iare.ac.in. So that is generally used by the humans. Now the question is, how to map between these IP addresses as well as the iare.ac.in. So for that, the application layer provides one protocol, that is the DNS, Domain Name System. So that is a distributed database which is implemented in hierarchy of many name servers. So what does that mean, hierarchy of many name servers? We will discuss later. Then coming to the DNS services. A hostname to IP address translation, that is the basic service of any DNS. Conversion of hostname to IP address translation, just like IARE.ac.in to some IP address. Then host aliasing, that is canonical as well as the alias names. So here we can use many names for a single host. And another service, that is a mail server aliasing. Then load distribution, which means that replicated web servers. So we have set of IP addresses for one canonical name. See, based upon these DNS services, we can easily explain what is the working of that particular DNS. For example, if you want to go to a certain website like www.iare.ac.in, first of all, you would open your web browser and you need to type in the domain name of that particular website. So let us take www.iare.ac.in. Now, technically, you really don't have to type iare.ac.in to retrieve that particular web page. Just you can type in IP address. Instead of, if you already know the IARE's IP address, but since we are accustomed to memorizing and dealing with numbers, so for simplicity purpose, especially whenever there are a number of websites on the internet, right? So we just type in the domain name. Instead, just we can DNS, automatically the DNS convert it to the IP address for us. So the DNS, which stores all the domain names with the respect to IP addresses. As a human beings, we don't know exactly what is the IP address of each and every server or whatever the form we need. Just you need to type directly iare.ac.in. But DNS can access that particular iare.ac.in with the help of the IP address. See, whenever we need to type iare.ac.in in our web browser, then automatically the DNS server will search for that through its cache memory to find a matching IP address for that particular domain name, iare.ac.in. So there is some specification for that .in. I will explain later. Then when it finds, it will resolve that particular domain name called iare.ac.in to IP address of that particular website. Once that is done, whenever your computer is capable of communicate with a IARE web server and retrieve that particular web page. So this domain name system basically works like our phone book in our handheld devices. So whenever we want to find any number, you don't know exactly that particular number. So nowadays, that is very important because more than 1, 2, 3, up to 10 members, only we need to remember. So remaining, we don't want to remember all the phone numbers, but just the name of that particular professor or person. For example, I need to make a call to my professor. I don't remember the number, just I remember the person name. Then automatically, you do not look up that particular number first. Directly you take the mobile and look up the name to whom we need to call. So that particular number will map to that particular name automatically. So this is the process how the DNS access various IP addresses of the servers. So why not we don't have centralized DNS? First one is single point of failure and there's a huge amount of traffic. Then maintenance issues. There are a number of issues for that. Not centralized DNS. See, this is one of the application layer protocol. Here, various users can communicate directly with the application layer. All of us know that. But with respect to the DNS, how the DNS maps names to IP address. That is simply name translation. So the various name servers to communicate to resolve that particular names. So that is the importance of DNS. Now coming to the distributed hierarchical database. That is, how the DNS servers are categorized. See, we have .com DNS servers and .org DNS servers, .edu DNS servers, right? So this is the root node of DNS servers that is categorized into the various types: .com DNS servers, .org, .edu, .in, and so on. See, the best example for .com, yahoo.com, amazon.com. .org, any organization, pbs.org. .edu, right? UCF, IITs, UMass, some .edu. So now the client wants IP address for, let us take a simple example, amazon.com. So initially, each and every node doesn't require to access or to know that particular IP address. So client queries a root server to find a .com DNS server. See, that comes under this particular one, right? So .com DNS server. See, there are number of .com DNS servers, right? Like Swiggy, right? Flipkart, right? Amazon. So there are number of .com servers. Now, initially the client queries a root server to find .com DNS server. So what happens whenever the root server receives a message from the client just to retrieve the .com server, then the root DNS server will look into this particular .com DNS server. Now, then the client queries .com DNS server to get whatever the required server or site, Amazon.com DNS server. So again, once you can find, the client queries Amazon.com DNS server to get the IP address for that particular site or server, that is www.amazon.com. So what happens here? The DNS helps to the clients. We don't want to remember IP address of that particular Amazon.com. Just we know the name. Then automatically DNS helps to get the IP address for that particular server. See, these are the DNS root name servers. Root name servers. There are number of root name servers. Those are categorized into the various regions. So we have totally 13 root name servers worldwide. Worldwide, right? Like US, IARE, Verizon, right? NASA, Internet Software. So there are number of servers. Each and every server can map to one particular IP address. Then coming to the TLD and authoritative servers. So TLD means here the top level domain servers. Top level domain servers. What are those top level domain servers? So these servers are responsible for .com, .org, .net, .edu. There are number of top level domain servers. And all the top level country domains like .uk, .us, .france, .ca, .japan. So once the network solutions maintain the servers for .com top level domain servers, then if any organization comes under the educational societies, then EDU calls for the EDU top level domain servers. So what are the authoritative DNS servers? See, any organization's DNS servers which provides authoritative host name to mappings for organization server. Example, web and email. See, for example, we have different types of mail IDs, right? So that is one is a personal mail ID, another one is a official mail ID. So that particular official mail ID That is, for example, raja@iare.ac.in. See, this is maintained by organization, that is IARE, or whatever the service provider, right? So this maps to one particular IP address. So these are the authoritative servers, we can call as authoritative DNS servers, that is organization's DNS servers, which provides authoritative host name to IP mappings for organization server. So this can be maintained by organization or service provider. Then local name server. Local name server. So these servers doesn't strictly belong to any hierarchy. So each internet service providers has one, that is we can call as a default name server. Default name server. What is the default name server? Whenever a host makes a DNS query, that particular query is directly sent to its local DNS server. Whenever a host makes a DNS query, then that particular query is sent to a local DNS server. Right? So that particular local DNS server that acts as a proxy, that is the just like a intermediate memory, cache memory. Just it forwards query into the hierarchy. So once that particular IP address is mapped, then automatically whatever the request, based upon that particular request, that particular web page extracted. See, these are the iterative and recursive queries. See, for example, here the host at, this is the requesting host, this is the local DNS server, this is the TLD DNS server, this is the authoritative DNS server. For example, let us consider the host at cis.poly.edu. So this is one of the educational site. So once IP address for gaia.cs.umass.edu. See what happens here. We don't know exactly the IP address of that particular server, but here just we know the name of that particular server. Now automatically the query to DNS, rarely due to the cache of all TLD DNS information and at local DNS server. Right? See, first of all, the information is accessed from local DNS server. If it is not there, then automatically it transmits that particular request to the TLD DNS server. Right? So based upon this, the TLD DNS server access information from the authoritative DNS server. The authoritative DNS server, which consists of information, see here, umass.edu. Right? So now the information is extracted and that is transmitted to the requesting host. Those are iterative and recursive queries. See, this is the first step, second step, third step, fourth step, fifth step, sixth step, again 7 and 8. Now recursive queries. Recursive query. See, the DNS client requires DNS server which responds with either the requested resources record or an error message. So when generally error message will come stating that the record or domain name doesn't exist. So first of all, the DNS server accepts the request from the requesting host. Then it finds that within that particular local DNS server. Right? So whatever the requested page or site which is not available in the local DNS server, then it automatically transmits the same request to the root DNS server. So we know a root DNS server which finds based upon our request. For example, here I need to request IARE.edu. So that comes under the educational society. So automatically the root DNS server extracts the information from the .edu servers. If it is fine, then automatically it sends that particular request to the authoritative DNS server like IARE.edu. Then within that, whatever the client needs some data, that particular data is extracted from the authoritative DNS server to the root DNS server and then local DNS server. Finally, it transmits to the requesting host. See, for example, I need to extract data like Krishna as a professor who works at IARE. But I don't know at present he is working or not. But I know his only name. So I need to extract his profile. Then automatically I search IARE.edu, for example. My node acts as a requesting host. Then the particular request transmits to the local DNS server. Right? So within that particular local DNS server, that particular professor name doesn't exist, then automatically it identifies from the root DNS server. So what happens? Root DNS server extracts that particular page with the name of some professor name with the IARE. Then that particular root DNS server transmits the same request to the authoritative DNS server. If it is available in that particular IARE website, then it extracts that particular information and transmits to the requesting host. If not, the DNS server responds with either the requested resource or an error message which states that the record or domain name doesn't exist. So whatever the name, that is a professor name, the requesting host requests, the professor is not available, then automatically states that there are no records with the requesting name. So those are recursive queries. Then iterative query, that means which contacted the server, replies with the name of server to contact. I don't know this name, but ask this particular server. So that is generally happens. So whenever we need to access any profile of some particular professor or scholar, so if it is not available, then it shows that the same that we can call as a matching profiles, right? Either first name or last name, anyone is matching, then it shows all the profiles of that particular names. That is the iterative query. Then DNS catching and updating records. Catching and updating records. See, once any name server which learns mapping, then it catches that particular mapping. So the catchy entries timeouts, that is disappears after some time, then we need to refresh a particular copy. So in case of updating records, the TLD servers typically catched in local name servers. So that is the root name servers are not often visited. See, then DNS records. So this is very important here. How the resource records are extracted, how the resource records are stored. So DNS, that is a distributed database storing resource records like this. So this is the format for a resource record. Name, value, type. See, for example, type A, the name is host name, the value is IP address. Right? For example, the type is NS, that is the name is domain, any domain. Right? Like example, FOO.com. So any commercial website, Swiggy.com, Zomato.com, something. Then the value is IP address of authoritative DNS server for this particular domain. So we know the name Swiggy.com, for example. The value is what is the IP address of authoritative DNS server for that particular domain. Then type is MX. Here the value is name of mail server associated with name. Then another one, if the type is a CNAME, that is a name is alias name for some canonical. So the best example is IBM.com. Is really server is.backup2.ibm.com, let us say. So here the value is canonical name. That is the real name of that particular requested name. Then important one is DNS protocol and what is the message format for DNS. So DNS protocol here query and reply messages both with the same message format, right? So we know the protocol is set of rules and regulations. So whenever the requesting host, or we can call as a client node, may send some query regarding accessing some particular site or web page, then the reply message, which is also with the same message format. See message header. This is the message format. At the top, identification, then various flags, then number of questions and number of answers, number of authority and number of additional errors. So questions, those are variable number of questions, answers variable number of resource records, authority variable number of resource records and additional information. See the message header basically the identification which consists of 16-bit for both query as well as the reply. So what are the various flags, right? So whether that particular flag which represents that is a query or reply or any recursion desired or any recursion available and reply is authoritative. See the top three which occupies the 12 bytes, that is identification, number of questions and number of answers, number of authoritative requested queries. See, let us take DNS protocol as well as the messages that is particularly meant for the connectionless systems. So that is the UDP 53. See here, these are all the common, but the name and type fields for a query, so which comes under this variable number of questions, and errors in response to query, that is answers, and records for authoritative services, that is authority variable number of resource records. Similarly, any additional information that may be used. So in this way, we need to access the messages from the connectionless systems. Then how we need to insert records into the existing DNS. Example, just created a startup that is a network Utopia. Then we need to register that particular name, networkutopia.com at a register site. So generally this is helpful for any startups. So here we need to provide the register with the names and IP addresses of our authoritative name server, right? So once it accesses the primary as well as the secondary authoritative name servers, then register inserts these two URLs into the .com TLD server, because here we need to register with the help of networkutopia.com, right? See networkutopia.com, dnsl.networkutopia.com, nsdsnl.networkutopia.com. So this is the IP address 212.212.212.1. Then put into that particular authoritative server. So that is dnsl.networkutopia.com. Then here the A, which represents type. So we know the format of resource records, right? You know the format of resource records, that is the name, type, value. So type A, records for www.networkutopia.com. Then type C name for networkutopia.com. So that is the alias name. Then MX record for networkutopia.com. That is the for email purpose. So within that particular email, Also type a record for the email server. Now, how do people get the IP address of this particular website? dnsl.networkutopia.com. So that is the functionality of DNS, right? Which maps names to the IP addresses. So directly the IP address of that particular requested name can access with the help of this particular name and maps with the IP address, right? So that represents the DNS, domain name system. So in this video, we discussed about what is DNS, what is the purpose of DNS, how DNS evolves, and what are the various hierarchical databases of DNS. So what are the various servers like .com, .in, .edu, and how the requesting node may access the information, that is how that particular name which maps to the IP address, and how we need to inserting records into the DNS. So this deals about the DNS, domain name system. This is one of the important protocol or DNS in application layer. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.